Alexa, turn on Office.
Okay.
Hey, what's up? Nasir Malik here. It's been a while since I have posted a tutorial. I apologize for the delay. I will be posting more frequently from here on. In this tutorial, we will be doing a similar project as we did for the tutorial 2, but in this project, we will use Pi 3 instead of ESP8266 board. We will control Pi 3 attached relay with voice command through Alexa. Let's get started. For this project, you will need following components: Amazon Dot or Echo, micro SD card, a Pi 3, a relay, micro SD card reader, micro USB cable, and 3 female to female breadboard wires. I will not be using breadboard in this project since there are only 3 wires that are required to connect the relay to the Pi 3 board. So here are some of the steps we'll be doing to get this project completed. First, we will download and install Raspbian on an SD card. You will need a PC for that, or Mac. Enable SSH and Wi-Fi without a monitor and connect through a VNC client. Download PuTTY and access Pi 3 over SSH to install and update software. Update and upgrade Pi 3 over SSH. Download and run IoT program from GitHub. I have already uploaded the code for this project to GitHub. I will include a link below. Control Pi 3 attached relay with voice command from Alexa. For this project, connecting relay to Pi 3 board is very easy. You only need 3 wires that need to be connected. So as you can see on the relay, the minus wire connects to the ground, which is pin 6 on the board, or the ground. A positive wire connects to 5-volt power on the Pi, which is connector number 4 on the board. And a signal wire connects to the GPIO 4, which is pin 7 on the Raspberry Pi. So for this project, I have already uploaded the code to GitHub. I will include this link in the video. I also have written detailed instructions on the GitHub. You can follow them step by step. There are some steps that are optional. So the first step we need to do is hook up our relay to the Raspberry Pi. You can control any devices up to 10 amp. As you can see on this relay, the first pin is negative, middle pin is positive, and the third one is signal. So let's connect this. So I have these 3 wires. I'm going to connect a negative, a black wire to the negative, black wire to the negative, white wire to the positive, and the gray wire to the signal. Like so. And on the other end, we will connect this directly to the Raspberry Pi. If you're holding your Raspberry Pi like so, starting from the top, this left first pin is number 1, then the next one is number 2, number 3, number 4, number 5, and you keep counting down all the way to the end. So for the ground on the board, we need to connect it pin number 6. So we'll take our ground and we connect it to pin 3. Now we need to connect our VCC or 5-volt power pin on pin number 4. So if you count 1, 2, 3, 4, so white 1 to the 5-volt. Sorry, I can't see. It's difficult, looking through the camera trying to connect is difficult. So we have lost wire, which is a signal. For this project, I'm going to use GPIO 4. So if you count, it's the pin 7 on the board. So if you do 1, 2, 3, 4, 5, 6, 7. So that's the 4th pin. If you look at it, 1, 2, 3, 4th. So that's it. It was very simple to connect relay to the Raspberry Pi board. That's all we have to do. So now we need to grab our mini SD card and connect it to our PC to format and flash it with Raspbian. So we'll take the SD card, put it in the SD card adapter, like so, and connect it to our computer. Once you connect it to your computer, go to Windows Explorer and look for your SD card drive letter. In my case, it's I. I would right click and format my SD card. You need to make sure you format into FAT file system. And you can click start. And it would give you a warning that it's going to delete stuff on the disk. That's fine. Quick format is completed. We're done. So at this point, your SD card is formatted and it's empty. We need to install Raspbian on it. To do that, we need a couple of software downloaded. They're in the GitHub documentation also. I'll include the links in the video also. To download Raspberry Pi OS software, we need to go to raspberrypi.org, download page, and we will download Raspbian JC with Pixel. So you can download a zip file. As you can see, it's downloading. You will also need to download Win32 Disk Imager. You will click on this link and wait for a few seconds, and the download save as window will appear, and you can save it locally. So once both programs are downloaded, you go into the Windows Explorer, unzip the Raspbian zip folder. So once the Raspbian is unzipped, if you go into the folder, you see this image file that we need to put on a SD card. Next, you will install the Windows 32 Disk Imager. Say yes here. Select the agreement, say next, next, install. So from Disk Imager, you select the image file. Go to Raspbian, select the disk Raspbian disk image file, and my SD card drive letter already selected, and I will click write and say yes. This will take about 20 minutes to install. I'm going to pause the video and come back when this is finished. Okay, Disk Imager completed copying image to the SD card. Now we need to go to Windows Explorer, select the SD card drive letter. On the root of the SD card, we need to create following two files. SSH file without any extension, it should be empty. And the second file is wpa_supplicant.config. So I have already added my SSID and my password. I'm going to save the file, and I'm going to rename the file the same name as this file. So you rename your file to this name. And that's it. At this point, we're done preparing our SD card with Raspbian OS for Raspberry Pi. Also telling on the boot time to enable SSH and Wi-Fi and connect it to our access point or our Wi-Fi router. So at this point, I'm going to take the SD card out of the SD adapter and put it into Raspberry Pi. So now we're going to connect the Raspberry Pi to a power source. So once the Raspberry Pi is connected to a power source, you wait for a few seconds. In Windows, go to Run, type cmd, and type arp --a command to look up the IP address for Raspberry Pi. This command shows you all the IP addresses and physical addresses on your network. To find the Raspberry Pi IP address, look for the physical address that starts with B8-27. This may be different for your Raspberry Pi version 1 and 2. But for the Raspberry Pi 3, the MAC address usually starts from B8-27. So once you find the MAC address, look for the IP address on the internet address column. And this is your IP address. Note this IP address because you will need this to connect your SSH session and also VNC into the Raspberry Pi. When you close this window after you note the IP address, next you need to download PuTTY. I will download the 64-bit version. Once it's downloaded, I can open it. I can run it. In here, you will type in the IP address. This is my Raspberry IP address. And I will click the button Open. And it will give you this warning message. You click yes to this warning message. And this is your Raspberry Pi command line. To connect to SSH session of Raspberry Pi, the default username is Pi. And default password is Raspberry. And voila, you're connected. So from this Raspberry Pi command line, you can do basically pretty much everything. But for some people, they would like to do some of the stuff through a UI. This is optional. You can install the VNC if you need to connect to the Raspberry Pi desktop. To do that, you'll need to do following. You need to type following command: sudo space raspi-config. And you would go to interfacing options, select VNC, hit enter, select yes to enable it. VNC is enabled, say OK. And you click finish. So at this point VNC is enabled. So if you have downloaded the VNC client, you will simply put in your IP address and launch it. It will give you this warning, say continue, and voila. We're in the Raspberry Pi desktop. And you can turn on and off different interfaces from here and do a lot of things without the command line. But this is strictly optional. So we're done with this. So next what we need to do is, the very first thing you do is you need to update and upgrade the Raspberry Pi. To do that, you type in two commands: sudo apt-get update and upgrade. So this is updating to the latest packages. I'm going to pause and come back when this finishes. Okay, it completed. Next we need to give this command: sudo apt-get upgrade. It says, do you want to continue? Say yes. Type in Y and enter. And this process is going to take a while, so I'm going to pause the video here and then I'll come back when this completes. So finally, upgrade command completed. Next, what we need to do is download our GitHub project and unzip it. To download it, you will use this command. And the command you need to type in without the quotes. It's a wget space and then the URL. So you just finished downloading the zip file from the GitHub. And you can see the zip file is master.zip. To unzip it, you will simply type unzip master.zip. And you will see the GitHub project IoT-IP3-Alexa-automation-master. So we need to go into this folder, type in cd select and click, and it will automatically copy the folder name. So these are the same files that you see here, all of these files. So usually when you create a Python project, you create a virtual environment. This is optional. For this tutorial, I have the step listed in there, but you don't need to go through those steps. You will execute the following command: sudo space python3 space rpi underscore name underscore port underscore GPIO.py. So this is the file you will run to start your program on your Raspberry Pi that will start a server and start listening to Alexa commands. So you hit enter. And now the program is started on Raspberry Pi and it's waiting for Alexa to give it commands. In my Python code, I have typed in the device name Office. You can change it to whatever you want. You can simply go in here and change this text from Office to whatever. So whatever name you want to give this device, and Alexa will recognize it. So we'll go back, and the Python is in listening mode right now. So I'm going to go ahead and give it a command to Alexa to discover devices on my network. Alexa, discover devices.
Starting discovery. This can take up to 20 seconds. If you have Philips Hue, press the button on your bridge. Discovery is complete. I found one smart home device. If your Philips bulbs were not discovered, please press the button on the bridge and rerun discovery.
As you see, when I gave command to Alexa to discover devices, it sent a broadcast to discover devices on my network, and my Raspberry Pi is showing that it is responding. So next, I'm going to tell it to turn on and off this relay. You should see the LED light going on and off, and also you should hear the relay clicking. Alexa, turn on Office.
Okay.
Alexa, turn off Office.
Okay.
So as you can see, it is responding to the commands. And this is the easiest way to set up your Raspberry Pi to connect to Alexa and control devices. So for this project, this is it. One thing to keep in mind that the Raspberry Pi doesn't have any analog inputs. In next few projects, we'll do a project where we connect Raspberry Pi to, so we'll connect the Raspberry Pi to Arduino Uno or Arduino Nano, and they have some analog inputs. And also we'll work with some of the digital to analog converters that we can use with the Raspberry Pi. So we'll do some project with the temperature and humidity sensing. So for this project, this is it. Till next time, thank you very much. Bye.